Hi everyone, so today we're going to go ahead and review polynomials and rationals. In this question, we're going to go ahead and find which equation represents the polynomial. Now we have some zeros here. We have 1 at 6, and then we also have a negative 2i. Now the thing you need to remember is that imaginary solutions always come in a pair, so even though the plus minus is not written, it is there. So what you see is that you actually have 3 total zeros, which means that has to be my degree. So it cannot be C, it cannot be D, and it cannot be E. Now you're going to have to determine between A and B which one is going to have that 0. So what you're going to do is you're actually going to use the 0, that's the 6, because that's a real 0. And we're going to try synthetic division with letter A as well as with letter B. Now, with letter A, we're going to put 6 on the outside of our synthetic division, and we're going to try 1, negative 6, 4, and negative 24. Now, remember, if the 6 is a 0, then the remainder is going to have to be 0. So we're going to drop down the 1, multiply gets us 6, then that's going to get us 0, and then 0, and then 4, and then positive 24. And because that remainder is 0, that means that 6 is a 0 of letter A. Now we're going to also confirm letter B to make sure. So we're going to try 6 again. You have 1, 4, negative 6, and 24. 1, you have 6, you have 10, you have 60, you have 54, you have 324, and then you have 348. So this is your remainder. Now, because that the remainder is not 0, in letter B, 6 cannot be a 0 of that polynomial, which means our answer is going to be letter A. Okay, here we are finding the remaining zeros of our equation given the 0, x is equal to 2. So we're not going to change any signs. We're going to put 2 here, write our coefficients. We've got 6, we have negative 11, we have negative 3, and we have 2. So let's drop. You're going to multiply, you're going to add, you're going to multiply, you're going to add down. We're going to multiply, and we're going to get a remainder of 0, which is what we should have. Okay, so remember when you're writing your equation, we had dropped down a degree. So this is really your x squared, this is really your x, and this is really your constant. This gets you 6x squared plus x minus 1, and it's going to equal 0. Now you're going to go ahead and factor this, so you can use your box, or you can do guess and check, or you can do split the middle. So you got 6x squared, you got plus x, and then a minus 1. So we're going to go ahead and try 3x and 2x, and then we should have 1 and 1 to get us that 1. We're going to go ahead and try a negative 1 and a positive 1 there. So we'll try this one out. This is negative 2x. This is a positive 3x, so that works out. So your two factors are 3x minus 1 and 2x plus 1, which equals 0. So when I go ahead and set each of those equal to 0, I have first answer of 1/3 and the second answer of negative 1/2. Okay, so in this question, we're going to go ahead and find all the zeros of your function. So right now what you're going to have to do is you're going to have to graph in the calculator in order to get some of your zeros. Okay, so your zeros were negative 1 and 3, so you're going to use those zeros to do synthetic division. So again, doing synthetic division makes your polynomial into something smaller that you could actually work with. So we're going to do negative 1 here. Let's do that first. So you got 1, negative 6, 12, negative 2, and negative 21. We're going to drop, and you've got negative 1, you have negative 7, Then you have a positive 7, you have 19, you have negative 19, you have negative 21, you have a positive 21, and you have 0, which is what we want. And then you're going to use the second 0 with the same numbers and just do synthetic division one more time. So you have 1, you have 3, you have negative 4, you have negative 12, you have 7, you have 21, and you have 0. Now, because you did synthetic division twice, the x to the fourth becomes x to the second. So this is x to the second, x, and then your constant. So this becomes x squared minus 4x plus 7, and that's equal to 0. Now, this is not factorable, so we are going to use the quadratic formula in order to solve. So you have the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So you've got, let's see, 4 and then plus or minus, you're going to get negative 12 over 2. Now, the negative 12, don't forget, does break down, and you're going to split that off into where you're going to get the I due to the negative 1, and then you're also going to simplify that 12. So that 12 breaks down into 4 and 3, which in turn breaks down into 2 and 2. So you're going to get 4 plus or minus, you're going to have 2i and then root 3, and then all divided by 2. And that's going to simplify to, these all reduce. So 2, 1, and 1. So you're going to get 2 plus or minus I square root of 3. Okay, so in letter B, let's go ahead and look and see how we can factor. So again, use the same sort of quadratic techniques. So you can do your box. Now instead of x and x, you're going to get x squared times x squared. That's going to get us x to the fourth. And then I need to get to negative 20, but then add to a negative 1. That's going to get you negative 5 and a positive 4. Now, what I'm going to do is I'm going to say, okay, then I have x to the second power minus 5 and x to the second power plus 4. And those are again going to equal 0. When I set each equal to 0, we can go ahead and solve. So you're going to add 5 to both sides, take the square root, and x is equal plus or minus the square root of 5. So that's one answer that you have. And then the next answer you're going to have is setting x squared plus 4 equal to 0. Subtract 4 from both sides, take the square root, and x is going to equal plus or minus. Now, because you have negative 4 under the radical, you are going to have an I, and 4 is a perfect square, and that's going to get you the 2. Okay, in question number 4, we are doing synthetic division, and we can look to see our 0 is going to be a positive 3. We're going to fill in our information. So look for any missing terms. You do not have an x squared term. So you're going to have 2, you're going to have 0, you're going to have negative 4, and you're going to have negative 3. We're going to go ahead and, let's say, drop the 2, multiply, add down, multiply, add down, multiply, and add down. So this from x to the third becomes x squared, with again a remainder. So when you write your answer, it's 2x squared plus 6x plus 14 with your remainder of 39, and that's going to go over your divisor. Okay, so for number 5, we're going to sketch the graph of the polynomial function. If it's an odd degree, you know that the ends are going to be opposite. And if it's a negative lead coefficient, again, thinking about that an odd degree is kind of like what a line looks like. And if it is a negative lead coefficient, that's like a negative slope. So your ends are going to look something like a line that has a negative slope. When you have the 0 with a multiplicity of 2, that is where your graph will bounce. And then when you have a multiplicity of 1, you're just going to pass through. So we're going to go ahead and figure out that we are looking at -2. Multiplicity is going to bounce. You're going to have a 0 of 7, and that will pass. Okay. So what we're doing is we know that the ends have to be opposites of each other due to the odd degree, and we have a negative lead coefficient. So I know I'm going to start up here, and I have to end down here. So I'm going to go down, and I'm going to touch that blue x-intercept, and I know that I have to bounce. And I know when I come back down to pass through the 0 of 7, I got to cross right to the other side of my x-axis, and I'm going to pass through going down. It's going to end negative. So in letter B, we have an even degree, and we know that those ends are going to point in the same direction. We are looking at a positive lead coefficient. So again, an even degree, kind of think about your parabola. So if we have a positive lead coefficient, we know the ends are somehow going to point up in the same direction. Again, with a multiplicity of 2, that will bounce. And with a multiplicity of 1, these will pass through. So now let's go ahead and look at -5. So here we're going to bounce. At 0, here we're going to pass through. And at 4, here we're going to pass through as well. So here we have same direction, both pointing up. So my ends are going to look something like this. So I know I'm going to come through to the -5. I have to bounce. I have to pass through the green at 0, and I have to pass through the red at 4. Okay, here in number 6, we're going to go ahead and describe the end behavior. So you're going to go ahead and look at the fact that you have an odd degree and you have a negative lead coefficient. So again, thinking about odd degree being like a line, you're going to look like a line that has a slope of a negative. So look and see what my ends are doing. I am starting off on the left side of my graph, pointing up towards positive infinity. And on the right side of my graph, when my x approaches positive infinity, I'm pointing down towards the negative y values or towards negative infinity. When you're looking at real zeros, again, you are looking at the degree. So you have 7 real zeros. And when you're looking at the turning points, you're taking that value of the real zeros, which we'll just say is n, and we're going to subtract 1, and that will get us our turning point. So 7 minus 1 will get us 6. So in number 7, we're going to go ahead and solve the polynomial inequality. You want to first make sure that one side of the inequality is 0, which it is. You're then going to go ahead and factor. So you can find all the real zeros. And these were again called your critical numbers. So we're going to go ahead and factor. So again, using your box is great. You are going to have x minus 6 and x plus 3, again staying greater than or equal to 0. So now you're going to go ahead and give the answers. So you have x is 6 and x is -3. So these are your critical numbers. These are going to go on your number line. So you have -3 as well as a +6. Now, the next thing you want to do is determine which of the intervals satisfies the inequality. So you're going to go ahead and look and see. You are looking for a positive, so a greater than. So we're going to pick some values that, let's say, would be outside of those critical numbers. So you've got -5. We'll try that here. We'll try 0 here, and we'll try 8 over here. So what we're going to do is take -5 and plug it in and see what I get. So -5 minus 6 is going to be a negative answer. And my negative answer times, and then -5 plus 3 is again a negative answer. So negative times negative is a positive. If I plug in 0, 0 minus 6 is a negative answer. And then 0 plus 3 is a positive answer. So I'd get a negative. And an 8 minus 6 is a positive answer. and 8 plus 3 is again a positive answer, so then I would get plus. Now, because you are greater than, you are looking for the positive again, so which inequality fits? So that would be positive here and positive here. So when you write your inequalities, you're looking at those intervals. So you're going to have as one part going from negative infinity all the way to negative 3. And again, because this is greater than or equal to, these are going to be closed circles. So that negative 3 is going to have a bracket, and then the U for union, and then positive 6 going towards positive infinity, which will have a parenthesis. And you can also think about your inequality. So you do have an even degree with a positive lead coefficient. So you know your ends are going to be pointing in the same direction up. So you know how your graph's going to look like, and figure out where the positive and the negative intervals satisfy that inequality. So in number 8, we're going to figure out all the characteristics of this function. Now the first thing you want to do is factor, right? We do see we have some parts of our rational function that are factorable. So the top would be x minus 5 and x minus 2. And the denominator would be x plus 2x minus 2. You do have a common factor here that will cancel out. So for right now, we'll take that into consideration as we figure out what each characteristic is. So x-intercepts are the zeros of your numerator. So if I take x minus 5 and set it equal to 0, you get x is equal to 5. Or you can write 5 comma 0 as a coordinate. The next thing we want to find out is our y-intercept. So the y-intercept is if I plug in 0 for x, what would my answer be? So I'm going to have 0 minus 5 and then 0 plus 2, which would get me negative 5 halves. I want to figure out what my vertical asymptote is. And the vertical asymptote is the zeros of your denominator. So if I take x plus 2 and set it equal to 0, I get x is equal to negative 2. If I want to figure out what my horizontal asymptote is, I'm looking at the degrees. So I need to figure out if we're even Stevens, if we're top heavy, or if we're bottom heavy. This is even Stevens, so I look at my lead coefficients. So that would be 1 over 1, so y is equal to 1. Now we're going to figure out what our slant asymptote is. And the slant asymptote is that the degree of your numerator has to be exactly 1 greater than the denominator. So in this case, we don't have that because they are even Stevens, so this has no slant asymptote. We do have a whole. Now the whole was that common factor that we canceled out earlier. So that means you're going to get x minus 2. So that means your x-coordinate is 2. And if you want to figure out what your y-coordinate is, you're taking that 2 and you're plugging it back into your equation. So I have 2 minus 5 over 2 plus 2, which is negative 3 over 4. So that negative 3/4 is the y-coordinate of my whole. So now to find the domain, you will have to graph so you can check. Here is what the graph will look like. It almost looks like the domain is all real numbers except for that vertical asymptote, which you had at negative 2. But don't forget that you do have a whole. So you do have that negative 2 with the vertical asymptote, but where 2 is, you do have a whole right here at 2 negative 3/4. So the domain is going to be this first piece, so negative infinity going all the way to negative 2. And then we're going from negative 2 to positive 2 because it kind of stops you right there for the whole. And then you have going from 2 to positive infinity. Now, if you think about end behavior, you're looking at what's the value that your function approaches. So as x approaches negative infinity, my function is right at that value there where it's at 1. And then as x approaches positive infinity, my function is going this way and again approaching that horizontal asymptote, which is 1. And number 9, we're going to solve a rational inequality. So the first thing you want to do, just like when you're solving a polynomial inequality, is that you want to make sure that 0 is on one side of your inequality. And then on the other side, you want to make sure that you have a single fraction. Now you will have to find critical numbers. The critical numbers are going to be the zeros. So it's what's going to make your numerator equal to 0. And this one can be either open or closed. So you want to look at the symbols. You want to be careful on that. So the other critical numbers is whatever those undefined values are. And those values are what make your denominator equal to 0, and those will always be open. So now let's go ahead and figure out what your critical numbers are here. So we're going to find the zeros, and that's going to be setting your numerator. So 5x plus 2 equal to 0. So you're going to subtract 2, and then x would be negative 2/5. So based on the symbol that you have, I know that because it's less than or equal to, this one is going to be closed. Now to find the undefined values, your denominator, so 3x minus 4 equals 0. Add 4 to both sides, x is 4/3, and this one will always be open. Now we're going to make our number line. We're going to make our negative 2/5. You're going to make that a closed circle. And then you're going to make your 4/3 an open circle. So now you're going to go ahead and test some numbers. So we can say that this one is 0. We can say this one is 2. And we can say this one is negative 3. So we got negative 3. So you've got 5 times negative 3 plus 2 over 3 times negative 3 minus 4. So again, you're just plugging in those values into your rational. So you're going to get a positive answer here. You're going to get a negative answer here. And you're going to get a positive answer here. Now again, because your symbol is a less than or equal to, I am looking for what inequality is the less than or negative. So that would be between a certain interval only. So that is negative 2/5, comma, 4/3 with parentheses. So in number 10, you're going to find the equation of your slant asymptote. So remember that if the degree of the numerator is exactly 1 greater than the denominator, you will have to use either long division or synthetic division to find the equation. Now, make sure that when you write your equation, it's going to be y equals, and it's going to be the quotient, so without the remainder. So now you can look at what you're dividing by. Because this is a linear divisor, you can use a synthetic division. So I would take negative 3, so the 0 of my divisor, and I would put my coefficients, and I would do synthetic division. And you've got negative 3, you've got negative 1, you have a positive 3, and you have a negative 2. So again, I'm not looking at my remainder, right? I'm just looking at my quotient, so what my answer was. So y equals, and this is going to be 1x minus 1, or just x minus 1. Okay, so when you're trying to find the slant asymptote for question number 11, here we actually cannot use synthetic division due to the fact that you have 2x squared plus 3, and that is not a linear factor. So we will have to do long division. So we can go ahead and write, you have 2x squared, so what we're dividing by, and then you have a plus 3. So if you want to put 0x to maybe help you with your setup that might work out. And then plus 3, and that's divided by 4x cubed plus 2x squared plus 10x minus 5. Now, these are your steps that you want to make sure that you follow. You want to make sure that you divide. You're going to multiply. And then you are going to subtract. So we're going to take the first term, so 4x cubed divided by 2x squared, and that's going to get us 2x. Now, the 2x is going to be placed right above the term that has the x. So now we're going to multiply. So you're going to multiply 2x by every term that is in your divisor. So you end up getting 4x cubed. You've got a 0x squared, and then you have a plus 6x. You are subtracting. So this is the important thing to remember. You are subtracting a quantity. So that is going to change some of our signs here. So we're doing 2 minus 0, which is going to be just 2x squared. You were doing 10 minus 6, which gets you a plus 4x. And then you are going to drop that minus 5 down. After you do that, go ahead and repeat what you had. So you're going to divide. So you're going to take this 2x squared now, divided by the 2x squared, and that's going to get you 1. So that positive 1 is placed above the constant, and now you're going to go ahead and multiply. So again, 1 times everything that is in your divisor. So you've got 2x squared, you're going to get 0, and then you're going to get a positive 3. Again, remember, you are subtracting. So when you subtract, we are subtracting a quantity that will switch our signs. Our first term will cancel. 4 minus 0 is just 4x, and then negative 5 minus 3 is a negative 8. Now, you don't actually need the remainder because when you write your sign asymptote, you're only looking at the quotient. So you have y equals and then 2x plus 1. In number 12, we're going to go ahead and find each of these characteristics. A vertical asymptote is the denominator, set m equal to 0. We do have a term that will cancel out, so you're going to have just x plus 5 equal to 0. So my vertical asymptote would be x is equal to negative 5. In the next question, we're finding our horizontal asymptote, so that's even Stevens because we have x to the first, x to the first, and then you have 4 over 1, which is just y is equal to 4. Okay, so here you have a picture of this function. So for n behavior, as x approaches negative infinity, the function is equal to some number, and as x approaches positive infinity, our function is approaching or equal to another number. So what is that value? We can see that we do actually have a horizontal asymptote at y is equal to 4. So as x approaches negative infinity, our function is 4. So as x approaches positive infinity, my function also is approaching the value of 4. And our whole, if applicable, now we do have a whole because we were canceling out that common factor. Now that factor was just x. So if I set my factor, which is x, is equal to 0, well, the x is 0. So I'm going to take my answer now, and I'm going to plug 0 in for x here, and that's 0 plus 5. So you're going to get negative 8 and then a positive 5. So my whole is 0, comma, negative 8/5. Now I hope you found this video helpful. Don't forget to check out our other review videos so you can review more pre-calculus. Thanks for watching and have a great day.